Hi children, how are you? And this is me, your science teacher, with some topics about heart. In the last lesson, we have studied about the blood, the components of blood, and some interesting facts about the blood. And here, this is a lesson we are going to study about the very interesting organ that we always amazed when we talk about this organ, because we have a doubt about how this organ works without getting tired. So today we are going to study about the heart, the structure of the heart and the function, how it works, both the anatomy and the physiology of the heart, how it circulates the blood. So before we go to the detailed things, we just gather some information we have studied earlier in different places related to the human heart. So you may remember that you have studied the structures of heart of different animal groups, as we have divided five groups of vertebrates, and they have different structure of heart. All of them have heart but not the same, and the circulatory system is not same. So two important factors about the human heart we have to study while comparing to the other organisms. So you know human is a mammal, so we just use the word mammals. So if you take from the fishes to mammals, there are different development stages of heart we can observe. If you take the fish, it has a heart with two chambers. Amphibians have three-chambered heart, and reptiles have three-chambered but incompletely divided atria they have. And if you take the birds, the four chambers are completed, but still there is a difference between the blood circulation of mammals and birds. And if you come to the mammals have four-chambered heart with the double blood circulation. That's an interesting thing to study about this. So the important and interesting, the unique thing that we have mammals as human as a mammal have is that as a double blood circulation. So what is double blood circulation? How it functions? We come after studying about the structure of the heart. First, let's come here. I have drawn a diagram of the heart. First, we have to identify the location of the heart in human body. So always, just whenever we talk about heart, just people will just keep the hands in the left side chest, but it is not exactly in the left side, and it is just below the sternum. Right? We have a rib cage. All the ribs comes in, and there is a bone here that connects all the rib bones, and that is called sternum. Just below the sternum and in the middle of the chest, and little tilted towards left, but not exactly in the left side, and it is middle, but it is a little tilted towards the left. So that is the place, and it is a very important organ. And before we study about the anatomy and physiology, and there is a physics behind this organ, we have to uncover that. So what is the physics? And it is an organ always working, just pumping, right? Contracting and relaxing, the everlasting movement it has. So you have studied, and surrounded by some other organs, the heart is in the middle of the two lungs, and when it moves, and it will create, the two surfaces will create friction. You have studied the force that against the movement, and that friction can cause damages. So we have to protect our heart from this friction. And how it is protected? You can see, children, the heart is covered by a tissue called tissue, and in between the heart and that tissue, and there is a liquid is filled between them. So the heart is working and into the liquid. So it reduces. The liquid works as a lubricant. It reduces the friction. So that's the physics behind this. And if you go to the anatomy, you can see a human heart has four chambers. And previously I told the fish has two chambers. amphibians have 3 chambers, but it is completed in human, the birds, and continue in the mammals also. That we have 4-chambered heart, and the upper chambers are called atrium and the lower chambers are called ventricles. So we have 2 upper chambers, 2 atria, and 2 lower chambers, 2 ventricles. And I have clearly divided the heart into 2 halves. One is left half, the other one is right half. Left side heart has 1 atrium and 1 ventricle, and likewise right side has an atrium and a ventricle. So there is a clear purpose I have divided. I will tell you why I have divided. Okay, now this side is marked as left, but this is my right side. And what is it? So this is my left side. So here you can see, and this is the left side of the heart. If I take my heart and keep it here, and that is the left side, and this is right side. But while you see from other side, it look like right side, but that is, you have to see in this way. I take my heart and keep it clearly here, and that is left, and this is right side. This is right side, and these are 4 chambers, and you can see the left side of the heart and right side of the heart is completely divided, and there is no any sort of connection between these 2 halves. But if you take only the right side, both the upper chamber and the lower chamber, the right atrium and right ventricle, are connected by a valve called tricuspid valve. And if you take the left side, both left atrium and left ventricle are connected by a valve called dicuspid valves. So in the right side you have tricuspid valve, and in the left side you have dicuspid valve. So what else we have in the heart? So you can see the other things are tubes, blood vessels. And again, one more thing, I pause here and go just somewhere else to talk about the blood circulation. And if you take the human blood circulation, that is called the closed blood circulation. That means the blood never go out of the blood vessels. Only the component will be exchanged. The heart pumps the blood, and the blood goes through the blood vessels and distribute the materials they want to distribute and come back to the heart through the blood vessels. So it is a closed circulatory system. So what is the opposite of the closed circulatory system? That is obvious, an open circulatory system. And some animals like mollusca, the lower animal mollusca, have open blood circulation. So you may have a doubt, what is this open blood circulation? They have a heart. You can see this entire body, the heart. And heart pumps the blood. The blood goes to the body cavity, and it is not moving through the blood vessels. Directly it's just pumped into the body cavity where the pressure is highly reduced and it is absorbed. And later the blood diffuses slowly back into the heart. And again it is pumping. And it is diffused into the heart, and again it pumps. So the efficiency is low in this case, but here higher efficiency. Okay, now you can see there are 4 chambers, the left side of the heart and right side of the heart. There are valves, and now we have to connect the tube system. One brings the blood out of the heart, and one brings the blood to the heart from the other organs. So now we fix. Right, you can see, and the heart is here, and this is the lower part of the body, and the upper part of the body, and there are 2 blood vessels. The main blood vessels, one carries the deoxygenated blood. The blood is supplying oxygen. After supplying oxygen, the blood becomes lack of oxygen, no oxygen in the blood. So we call that deoxygenated blood, and that comes from the upper part of the body and the lower part of the body. Right? So you can see, and the big tube, the blue color tube, is connected to the right atrium, the one vessel that brings the deoxygenated blood from the upper part of the body, the head and the arms region, and we call that blood vessel as superior vena cava. Superior vena cava brings the deoxygenated blood from the upper part of the body. Same time, the inferior vena cava brings the deoxygenated blood from the lower part of the body to the heart. Both deoxygenated blood from the upper part and the lower part finally comes to the right atrium. And the right atrium fills with the deoxygenated blood. And you can see once the atrium is filled and there is a small place, we call that SA node. SA node, and that produces an electric signal and it is spreading all over the tissue, the cardiac tissue of the atrium, and it causes contraction, sudden contraction of the atrial valve, and it pump the blood filled into the right atrium into the right ventricle, while the tricuspid valves will be open and the blood flow through this. And after that, you can see, and one more tube is connected to the right ventricle, and it goes out and divides into two. Then I will tell you why it is dividing into two. You can see clearly now the blood from the right atrium comes to right ventricle. Now the another place, we call that AV node, that give electric signal, electric pulse or shock, and it causes the ventricle tissues, ventricle muscles to contract very faster, and it contract. While it contract, this tricuspid valve will be closed and the backflow of the blood will be stopped. And you can see here there is a blood vessel, we call that pulmonary artery. Pulmonary means it is related to the respiratory system. So this artery brings the deoxygenated blood to the lungs. There are two lungs, left and right. That's why I divide into two branches, right? So you can see there is a valve, we call it semilunar valves. When it push, the valve open, tricuspid valves are closed, same time semilunar valves open, and the blood is pumped into the pulmonary artery. So pulmonary artery brings the deoxygenated blood to the lungs. See this clearly, to the lungs, where the deoxygenated blood gets the oxygen and is filled with oxygen, and again it comes back to the heart, but left side of the heart. Now this time it goes to the lungs, and where it is get oxygenated and come back to the left atrium, where it divides into four. You can see pulmonary veins are coming. There are two types of blood vessels. We can divide them into arteries and veins. Arteries means the blood vessels that bring the blood from the heart to the different organs. At the same time, the veins are bringing the blood from the body organ to the heart. So the pulmonary veins are bringing the blood from the lungs to the heart. That means the left atrium of the heart, and it is oxygenated. Now the left atrium contract and pump the oxygenated blood into the left ventricle. You can see when it contract, the dicuspid valves will open and the blood goes or flows into the left ventricle. Now the left ventricle is filled, and you can see there another tube or artery is connected. That is the main artery. We call it aorta. It's here you can see aorta, and that is the main artery that supplies oxygenated blood to the entire human body. Right, you can see here there is a valve at the beginning of the aorta, and that is called semilunar valves, like that you have seen in the pulmonary arteries. And when the left ventricle contracts, it's a very powerful contraction. When it contracts, the dicuspid valves will be closed and the semilunar valves will open, and the oxygenated blood pumped into the aorta, and the aorta distributes the oxygenated blood to the entire body. So you can see here clearly, children, the two sides of the heart. The right side of the heart pump the deoxygenated blood into the lungs, and the left side of the heart pump the oxygenated blood in throughout all over the body. So this is called as double blood circulation. That means before the oxygenated blood is pumped, distributed to the body organs, the blood is flowing 2 times through the heart. And we can divide that. The right side circulation is called as pulmonary circulation, as it pumps the deoxygenated blood into the lungs. And the left side circulation is called as systematic circulation, as it pumps the oxygenated blood throughout the body part. So there are 2 types of circulation. One is pulmonary circulation, the other one is systematic circulation. Pulmonary circulation is done by the right side of the heart, and the systematic circulation is done by left side of the heart. Now we have, right, is it contracting and relaxing 4 times, as I told here? No, right? You can see that both sides are working together. For example, I told you the deoxygenated blood comes from the inferior vena cava and superior vena cava, and it fills the right atrium. And at the same time, the oxygenated blood comes from the pulmonary veins and to the left atrium, and both are filled. And after both are filled, the SA node gives electric pulse, and both atria contract together, and they fill the ventricles. During atrial, this is called atrial contraction. Atrial contraction, or we can call that diastole, filling, right? Diastole. Both together contract together. The right atrium fill the right ventricle, the left atrium fill the left ventricle, and it takes 0.1 second. Right? Both atrial contraction take 0.1 second, and the electric pulse comes from this SA node, and after 0.1 second, the AV node gives this electric signal that makes the both ventricle to contract. This is called ventricular contraction or systolic pumping. Right? This pumping, systolic or the ventricular contraction, takes 0.3 seconds to pump the blood. The right side pump the deoxygenated blood through the pulmonary arteries to the lungs, and at the same time the left side pump the oxygenated blood through the aorta to all over the body. It takes 0.3 seconds. Right? After this contraction, both atria and ventricle become to their normal position. This is called intervene, or a relaxing position, taking rest, right? And it takes 0.4 seconds to intervene. So you can see 0.1 second for atrial contraction, 0.3 seconds for the ventricular contraction, and 0.4 seconds for relaxation. So altogether, and one complete workout takes 0.8 seconds, and out of 0.8 seconds, children, you can see very clearly 0.4 seconds the heart takes rest. That's why that is the magic or the secret behind is tireless work. So you don't want to think that if you want you can work without taking rest. Nobody can work without taking rest. And there are 2 secrets behind the heart without getting tired. One is it takes rest for every working cycle, and it is working rhythmically, not just going up and coming down. There is a rhythm of working. So if you also maintain a rhythm and taking enough rest in your work, and you can work like heart. So this is the wisdom we have to take from the heart. I hope you understand 2 these things, and this entire workout is called as cardiac cycle. And this is called cardiac cycle. It includes the atrial contraction or diastole, and ventricular contraction or systole or intervene. These 3 things together we call cardiac cycle. right? Cardiac cycle. One cardiac cycle takes 0.8 seconds. That means we call it one heartbeat. And you can hear 72 or 70 heartbeats while you are at rest, heartbeats for 1 minute. And you can see this very clearly in an ECG, electrocardiogram, or ECG or EKG. Some people are using as EKG, but the full form is called electrocardiogram. So what it says? Right, you can see they will fix some electrodes to your body and just monitor the tip. It says some lines up and down. So I told you here there are two nodes, SA node and AV node, and they are giving electric signals and it causes contraction of muscles. They are giving electric shock, right? Very small electric shock, and that causes a contraction of muscles, cardiac muscles. And by fixing electrodes to our body, we can take it into a graph. This is that, right? You can see, and there's a line and there's a up. It goes little up and again come down and goes higher, the very powerful contraction, and come down and then is filled up. So three things. You can see the cardiac cycle here. The first one, the smaller one, is small electric shock or a small pressure or force, that is atrial contraction. This two atria are contracting together, atrial contraction. And they fill the blood into the relevant ventricles, and the AV node give the electric pulse, and the ventricles are contracting very powerfully. It goes very up and come down, and this QRS is indicating the ventricle contraction or the systole. It takes 0.3 seconds, and after that you can see in both atria and ventricle just relaxing, coming to the normal position. The blood is filled, both atria is filled by blood, getting rest, just the normal thing. And this is a cardiac cycle, and this is how our heart works. The human heart or the other mammal's heart works like this, and we have a closed blood circulatory system at the same time, and the human heart is performing the double blood circulation. The one side of the heart, that means right side of the heart, performs pulmonary circulation. Same time, the left side of the heart performs systematic circulation, and that means before the oxygenated blood is supplied to the body, the blood goes 2 times through the heart. That is called double blood circulation, very special for mammals. Okay, that's all about the lesson here. We have studied about the structure of the heart and how it works, and in the next video lesson we'll learn something more about the function of the heart, and I will see you in the next video lesson. Until then, bye for now.